She is an experienced researcher and technology professional specializing in artificial intelligence, deep learning, and medical image analysis. She completed her bachelor's degree at Ramadev University, her master's and PhD at Changgung University, and her postdoctoral research at National Yangming Chiaotung University in Taiwan. She has been working in Taiwan since 2012 and is currently associated with Voltec Corporation. And today, the topic she is going to introduce is based on image processing methods. Thank you, ma'am.
Thank you so much for the nice introduction. Thank you, sir, for this invitation.
Yeah, you can start, I think.
Yes.
Let student join later. We can start. Yeah.
Okay, I'm going to share the screen now.
I've already made you the co-host. I think you can able to share. Yes, it's coming.
Is the PPT okay, sir?
Yes, visible. And you are also quite audible.
Okay. Okay, so today morning section, actually, I was also there, and I heard doctors, like the renowned doctor, his all advices, his concerns, and everything related to AI, and also some insightful questions. Actually, the things he had said, it's correctly actually the doctors currently, the physicians generally we say, they are facing that problems what they have mentioned. And about the questions like you are arising, like there are many networks, like somebody asks the graph neural network concept, and some person one I forgot the name for the sorry, but asked about how can the adaptability of AI, how the hospitals they are going to adopt it, like is there any rule regulation. Actually, AI is not new, but the application of AI in medical domain is currently progressing. I am not going to say it's new, but it's progressing stage. So many things need to be sought out. Many things need to be clear of. So we need to have patience, and together we need to work for that. Uh, Based on my 8 years experience of AI, because my PhD degree, my postdoctor is everything is the application of AI. Mostly my PhD is the application of AI in the ischemic data analysis, the non-contrast CT data, and my postdoctor I have done in the MRI data for the liver cancer diagnosis, image as well as the clinical data. But currently, then I shifted towards my domain, towards towards the industrial applications of AI. But I'm also associated with the hospitals for the clinical model development. So based on of your questions, because I found some of our audience as from the students background, some are from the medical background. So on the last day on 28th, because I know there are many questions related to application, how AI can be applied, because I think most of some of our physicians also in between the talks in some days. So in those days, if you have any questions or anything you want to know about how AI can be applied, or which data, or what kind of model you need to select, and all those things, then there is the second session. I remember on 28th, Dr. Puspanjali Gupta and I, we are not going to present anything on that session. We're like dedicated for you only. If any questions, any doubts, or any advices, or if any concerns, you please discuss it with us. And I think you have already seen our the agenda you have already seen, and here you can see most of the part like I have taken is like the, because what Professor Das has mentioned to us is just like a workshop related. Let's assume one person has no idea about AI or image, about especially the medical image, and how to start. So like what are the steps. Actually, there are many steps. With the time constraint, we cannot explain you more, but we will try our level best. My part is most the implementation part. Like if someone will get the data, then how he or she needs to start. So this one is like that's my part. So and the other like the professors and other researchers, they will focus on the like how AI is already applied in their respective category or will apply. So those part they will discuss. So mostly in my talks is just like physical, like the practical implementation of AI, coding, little bit theory, little bit application, little bit modeling. So if you have any doubt related to this, please feel free to ask me. So let's start. Introduction to image pre-processing methods. So before going to this, I would like to tell you image pre-processing. Actually, it should be like introduction to medical image pre-processing. But I have given a common like a name image because it's any kind of image. We need some kind of pre-processing. All the images. It's need little. We cannot take the raw data like we get the data from the doctor. We just cannot take the data and give it to the machine and we expect it will give us some better accuracy. It will give us some output, but that might not be our ultimate aim. So it to improve the accuracy, I am giving the name accuracy. It's not exactly the name performance metric accuracy. Accuracy means all our aim is to get better result. So to get the better result, we need, because all images like today doctor said, CT, MRI, echo, ECG, all these images have their respective, features. So we cannot just take the data and train our model. No, that cannot be. Currently, actually, this problem arises because currently OpenAI is very popular. We can just get the data, we can just get the code, run it, and get the accuracy. But now some students they are asking us, "Ma'am, why we are not getting the accuracy? Ma'am, why this code is not running?" So this is the thing. We need to first understand the data. Okay. So that before going to this, what is exactly an image? For us, it's just like, and we can see like it is like an image having some height, width. Actually, the machine always read it in terms of pixel. Okay, like an image, we can say it is divided into certain grids, we say, and it is one grid, we generally call it as a pixel. For example, let's say we say one image is 10 cross 10 size, means it is having 10 pixels in the row and 10 pixels towards column. So when you will discuss, when you will implement the image, you will not say it's an image, we can say it's a set of pixels. Then what kind of images are there? There are whatever image available in the world. It is divided into three types. The first type is a binary image. It's like two, the pixel value either 0 or 1. It's like a binary one. Or the next one is the grayscale image. Grayscale image means it's an 8-bit color value. We generally call how many pixels, like 2 to the power 8 to 256 values. So each pixel value, if I present, like for this one is a brain stroke image, the ischemic stroke image. When we like print these pixel values, here we can see these are the pixels because it is a grayscale image. So the picture, the value is, the pixel value is from 0 to 255. If we'll go for the RGB image, it having three channel, red, green, and blue. So each color having 8 bit. So each one is having 8 bits. So total is 2 to the power 24. So this many possible color values. So if you will see a particular image, this is an RGB image, this one is grayscale image, and this one is binary image. It's not from the appearance. Okay, binary image is always a 0 and 1, but sometimes the grayscale image, but like this image, one person can say it looks gray to our eye. So some person might say it is a grayscale image, but not exactly like that. When we downloaded the image from the hospital, we generally store it in a DICOM, DICOM, DICOM format. And when we see it's the what is the image type, then we can see it is actually RGB image. Already to our eye, it looks a gray, but the RGB pixels, they are like represented in such a way that it is actually RGB, but the color channels they are presented in such a way that it looks like a gray, but it is actually RGB. So that's also you keep in your mind. It's not like all the medical images, even it looks to gray, it is a gray. No, it is actually RGB. Then the next thing is why we need some kind of pre-processing. Okay. For example, this is the data I've used for my brain data analysis. So here we can see this part is actually my ROI, or we generally call my cerebral part. So here the other part, when we generally collected the images we converted from DICOM to JPG, like from 3D to 2D. Here you can see these are the unnecessary black color part, okay, which is really unwanted part. So if we'll give this to the machine, because of this unwanted part, it might be very large. So it might affect to some of my performance. So how about we only just crop those part or somehow disable this black color part? I only focus on this cerebral part. So that's why we need also image preprocessing. Another thing is that this one is a non-contrast CT image. Generally, the non-contrast CT for the stroke, brain stroke patient, especially the ischemic stroke patient, within 24 hours, we cannot see, the doctor cannot see, the physicians cannot see whether the person is really having stroke or not. So we have developed an AI model which can know whether the person is really ischemic stroke or not, and if it is, then which part is already affected, and what is the severity. So that we have already developed when I was working with the doctor in during my PhD. So, for example, this is one, and this part, it is not a medical image, but why I put this image? Because we have one, I have one project I was working. That one is like for elderly patient. Because in Taiwan they have many elderly care homes where the person how much food they are taking. For example, if the a diabetic patient, that person shouldn't take much sugary food. If it is a cholesterol patient, should not take more oily food. So when in the food cafeteria, they have the camera, and they need to capture the photo, and they will check what's the person exactly taking through AI. So in this case, when the plate is there, though actually we see the camera is more focused towards the plate, the AI model not towards the food. So in that case also we need some pre-processing. And here, this one is like intracranial stenosis. This is one something related to brain, like this is our artery, like this is the most MC artery we generally called. Here you can see this is the occlusion. Here is like some kind of narrowness or occlusion. And if we want to find out or the detect the occlusion, here you can see there are many surrounding arteries which are we just create the confusion for the model. How about we can only focus, do some pre-processing, and we instead of all this image, we can give this image to the only this part to the machine, so that machine can easily find out whether there is an occlusion or not. So this is like some examples why we need pre-processing. You might ask me like whether for all images we need this type of pre-processing. For from now I cannot say whether you need pre-processing or not based on your data, what's the data types, and whether it is needs pre-processing or not. Only after seeing the data we can only decide and what type of pre-processing it is needed. So some possible pre-processing generally we apply to the medical image. First one is the noise removal, and the second one is the cropping, and then the ROI extraction, and the morphological operation. Especially these four types we have generally we operate in our medical images. So first let's focus on the noise removal. The noise removal means when the images are not really very clear, some kind of hazy images. For example, here I put some not non medical images. For example, the person is taking capture. Here you can see the images are little hazy. Or maybe here you can see some kind of CT or MRI images when because of some external noise or maybe some internal noise. What is the external noise? When the person's capturing the because we use the CT and MRI machine to capture the image, and if some kind of fault is there in that machine, then we might get some kind of noisy image. Or maybe while after the capturing is done, and we need to enhance the quality of the image. Like for example, for the CT image, the non-contrast CT is not really enhanced. We need to enhance the little bit. Then we can also use some kind of inbuilt noise removal methods. So let's discuss one by one how can we apply the noise removal methods. The first thing is you need to read the image. Okay, the function is I am read, because all this course I'm going to discuss is already implemented in MATLAB, because MATLAB is very popular for the image pre-processing. But you can also apply Python and OpenCV, because for the maybe for MATLAB the function is I am read. For OpenCV there is some another functions, but it is the common steps. So you need to read this list. I am read, and if you want to show the image, this is your image. Then I told you, although the image looks like a gray color, the gray image, but it's actually an RGB image. So we need to convert into RGB to gray. Okay. So why we need to convert into RGB to gray, if someone will ask me, is because RGB, the color value is 2 to the power 24. The pixel value is very low, like 100, like 10,000, 100,000 of pixels. So this much pixel, one machine, when we will go for some kind of pre-processing operation, it's actually not a wise idea, and it's also time consuming, and also, we cannot get the exact output, because our code, how much it will affect on R or G or B, it's very difficult. So it's better, instead of that 100 million pixels, why we just consider to minimize it to within 256 pixel value. So generally we for the easy computation and to get the desired output, so we convert into RGB to gray. But if an image is already grayscale, you no need to convert. But how can you check whether the image is already RGB or there is it's a grayscale image? So it's just like a small code. You can print the rows, columns, and the number of color channels. Size of I means I is the image. And it can, like, if the number of color channel is 3, then it will print an RGB image. If it is 1, then it is a grayscale. And if it is like some other format, it will print some other thing. Then, for example, this image after conversion, when I printed it, it is shows it is a grayscale image. Then after that, we need to convert it into IM to double, but it is not always necessary. For this image, I used it. What is IM to double? Actually, here the images are like integer from 0 to 255, like 256. Again, the computational complexity is very high. It's not like we need to it. But at that time, when we developed this code, at that time we really don't have GPU, and the laptops we have used, because I worked these things at the year 2018, like around 7 years before. At that time, we don't have that much good hardware resources. So we have converted it into IM to double to again compress the pixel within 0 to 1 boundary. So for example, like this pixel value 100, 100, 508, now we'll capture it like 0.3, 0.4, 0.4, like more compact, we can say. So this is like one optional thing. If it is necessary, you can do. If it is not, then that's also fine. Then after that, we need to add some, because for the noise, before the noise removal, we need to add a little bit noise. Okay, you can ask me why we need a little bit noise of addition. I will explain you with an example. For example, if we know for the noise, before noise removal, when we see an image, we cannot say how much noise it is actually have. So what generally do? Suppose I give you a glass of Coke and a glass of black tea, and I'll tell you to differentiate which one is Coke, which one is black tea, just through glance. Can you say? No, you might get some difficulty to find it out. However, if we can put some like a Mentos in a Coke, then that one will come out, that the Coke will come up. So we can conclude, okay, this is Coke, this is black tea. This is the simple thing. We don't know how much noise already inside the image. How about we will add some known noise, and then we will check. So here we have added some IM noise is the function. Then this is my image. Then I have added the Gaussian noise. Then this is the mean and variance value. This is kind of like a user defined value, and it's based on different on image type. We have also different type of noise you can add it, like Gaussian, Poisson, salt and pepper noise, and how much is needed. You can, there is a hit and trial value actually. Then you will add this noise. Now, how to know how much noise is already present there? We generally calculate the value with PSNR, peak signal to noise ratio. I think in your if any persons in their BTech, they have already, or MTech, they have the image processing course, then I think they have already this one, like no, the peak signal to noise ratio, why we are using to find out how much noise it's already there. So now if we calculate with this PSNR function the noisy image and the original image, now we can see, oh, actually we have the noisy, the 31.8418. We just quantify the amount of noise. Okay, now we'll apply different types of filtering methods. Actually there are many, like some are like the spatial domain. This spatial domain means it will act on the pixel level. These are some age preserving filter. The age preserving filter actually will work on the age of the image. And there are some texture filtering image. It will applicable, it will change the texture of the image. So there are different types of like the filtering methods. But apart from these also there are many. Okay, I just put some important methods here. Let's apply first the median filter. Because of the time constraint, I can't show you the applications of all the how we can apply the filter. So here, like, we compare the PSNR value of the this median filter image and the original image. So here we can see, after applying the median filter, here we can see our value is 39.3654. Okay, means the better is the PSNR value. Better is the PSNR value means it is more enhanced. So here we can see if there is a comparison before noise removal and after noise removal. This is actually a non-contrasticity of the image. We want to see actually where is the stroke of this patient. Okay, so here we can see after this one, you can see this one is like little bit darker, but it is more enhanced. So instead of giving this image to the machine for any kind of training or testing, if you will give this one, then we can get the better improved accuracy. Actually, we have seen it. Okay, this one is like I have applied the Wiener filter, because each image, each filtering has different we can say, like the application or having the impact on the image. So here one comparison, like considering the that image, that brain image, and when we apply all the filter, then here we can see these are the all PHNR value. Here we can see the median filter actually gives us the better result. So for this application, actually we applied median filter. So this is kind of like one kind of pre-processing methods when we generally use the non-contrast data. We use the non-contrast CT for the brain stroke analysis, and also non-contrast CT for kidney stone analysis. So in that case, actually we applied some kind of filtering methods for enhancement of the image. Okay. So now this is some introduction to the noise removal methods. Now the next part is the ROI extraction we will discuss. So if you have any questions related to the noise removal or any part, because these are the 4 parts we are going to discuss, please note it down at the end. Maybe there are last 5-10 minutes we will discuss about the questions. Okay, some person have one question, please ask. Okay, but please keep your
Yatharth.
question to the last.
Just Yatharth. We'll take one question only, but
Yeah.
at last one you'll take the question.
Yes,
Yeah,
ma'am. You mentioned adding
Yes.
more noise during the Gaussian noise thing.
Yeah.
Can you elaborate a bit more on that? That sounded really interesting.
Oh, okay. Yeah, sure.
Thank you.
Actually, that's a question everybody always asks me whenever I presented this PPT. That's actually that's why I give you an example. Whenever we want to to know how much noise is present is that in an image, we need always a comparison factor. Okay, if I will if I will tell you, like, you are a more talented person or you are a very good student, but what is a comparison parameter? There should be another student with whom I can compare. Let's say Yatharth is a very good student in comparison to Sulagna, because I know Sulagna's capability, where Sulagna is very known to me, but Yathartha might not know because I don't know your capability or capacity. Okay, so there is something we need a comparison parameter. So to know how much noise it is present there, something we need to compare it with. So for that, we will add some known noise, and mostly for the city image, Gaussian noise is added. Actually, because of the sort of time, I need to discuss many things. One PPT actually there. If you will continue the work with you, there are 2-3 good researchers from the USA. They have already published the paper. We generally add Gaussian noise to the city image or MRI image. So this one is like very helpful to calculate the PSNR value. So that's why we add the Gaussian noise to, especially the non-contrast images.
Thank you, ma'am. I'll look more into it later.
Yeah. And in future, if you want to like some kind of collaboration or something, there are some other publications and maybe I can share, but there are actually some good PPTs for that. How Gaussian noise impact. Okay.
Yes, ma'am.
Okay. Yeah, that's one thing actually, because of the time constraints, because professor already said to me we need to discuss within 1.5 hour, and image processing, it's a class actually, like it's a semester of class, and if the AI is added, then it's like, oh my god. But I will try to focus some of the important things, and later we can discuss more if you will interest any of the applications. Okay, now if any other question, please keep it to the last, we will discuss it thoroughly. Next, go for the ROI extraction. This ROI extraction is very, very important actually. That one also we are implemented in our like the applications or the projects we have already worked. What is the ROI? Actually, this is like one kind of histopathology image of a colorectal cancer patient. Okay, so what exactly is like that? Here actually these are some of the cancer cells, or we can say that like how much it is there, like the cancer, how the appearance, whether there is any like a proper uniform appearance, or there may be some non-uniformity is there. So if we want to know whether there is some, how the cancer cells they are like the uniform or non-uniform, then why we just focus on that, those things. Our ROI, or we generally call the region of extraction, okay, sorry, region of interest, ROI. What's our ROI? Our ROI is only these things. Then why we will focus on this? So how we somehow we just only get this value, okay? So there are some image pre-processing methods. So instead of this image, we can just only give machine to this image, then we'll get some value. So that we call, generally we call ROI extraction, or some people also say called as image segmentation. Here, like some images I put, for example, these are like ROI inside a microscope. Okay, here we can see, so these how these tiny cells are looks like. So you can see this black color as our background, but our more focus on these cells. And this one is actually an hemorrhage patient. This one personally I worked on actually. This one here you can see this hemorrhage. Actually, we want to know the progression of the hemorrhage. Actually, I have worked on a project. We want to see, suppose a patient's hemorrhage happened now. So because the how 2-3 days, whether it is a real progress or there is a false progress, that we want to predict after 2-3 days when it is under observation. So for that one, actually, this skull part and all those parts, the surrounding arteries and all those parts are not necessary. So why not we'll just focus on this part? This is our ROI. So we extracted actually those parts. Okay. And this one we have already discussed. So what are the image like the ROI extraction methods are there? There are actually many actually, and I put some of the important or traditional methods actually. But currently, people who have already worked on these or working on those pre-processing ROI extraction method, segmented method, there are currently actually many more. You can explore it more. So first one is the threshold based. There are two types, divided into global thresholding as well as the local thresholding. So for the global thresholding, only the global thresholding actually is a name. This is the first thresholding method. So this one is there. Then the next one is the Orsu's binarization. It's the very, very popular one. I think Orsu got a very good, I forgot which like award he like received, but he's a very, very renowned in that field. Then we have some local thresholding methods. Then we have some clustering based method. Then we have some contouring based method. Then we have some edge based method. Then we have some texture based, and this one is like more mathematical models. Okay, but all the methods we cannot cover it today. So in this session specially, so we will discuss one method in every type, so that you can find a different, like how all the methods will we can apply to our images. So first, let's go for thresholding based ROI extraction. So the first one is the image thresholding. When we will go, so in image thresholding, what generally it will do, we'll go for the find out the true and false value, okay, foreground or background, okay, because for example, here, which one is our foreground? Which one is our ROI? So in this case, the stroke region, the hemorrhagic stroke region is our foreground. Then in this image, which are in the background? The background are nothing but the surrounding part. So how can we differentiate from foreground to background using some threshold? Okay. So the advantage is it's remove unnecessary details, because if we'll focus on this is our ROI, this all are is like unnecessary details. We really don't need it, and bring out the hidden details. For example, for this images, actually, this one is not medical related. This one actually one of my friend is working. It's just like they are some ancient books. We can say in Odia we have like the pothi, we generally say, I don't know what we call in English, but like the pothi and some manuscripts, like the already like the very years ago, like very renowned, like the Gopabandhu Das on people, they have already written it, but it's like a hazy, we cannot get it what exactly written. So there's some kind of applying some thresholding method, because now they want to restore those parts. So now they want to apply some, actually they're working on the AI part, but before that, they are also using some kind of threshold to find out actually which part is not, we cannot see it, okay, properly. So some kind of like bring out the hidden details. So let's discuss first on the global thresholding part. What is the global thresholding? The first method, we need to find a threshold T, okay? And this one the researchers have developed. It's a very common one actually. If any threshold, if any pixel value, the XY is the pixel value, greater than that threshold, make it is 1. If it is less than the threshold, then make it is 0. Means ultimately we are going to get a binary image, because I've already said 1 and 0 is the binary. If one pixel value is 1 and 0, it is the binary. So through this threshold, our image is like a grayscale input, but ultimately we are going to get a binary image, but with our defined ROI. And when we are using a global thresholding, when there is a good contrast between the foreground and background. What do you mean by good contrast? Means if this white color and if I compare it with my background, is a good contrast. Okay, so we can apply this method when we get a good contrast. Then the similar way, we'll read the image, then we convert it into double. Then we are calculating, for example, the global threshold T. How can we calculate it? Okay, many persons here, actually you need to apply some of your mathematical formula, mathematical way, like how can you calculate a formula, okay, the T value. Here what I have used, I have find out the minimum threshold. The minimum threshold is 0, and I find out what is the maximum, the minimum pixel value is the 0, and what is the maximum threshold is the 0.85, the maximum pixel value, it is 0.85. Then here I have taken an adjust threshold, that is the alpha value. The formula I have derived here, adjust threshold into minimum threshold plus maximum threshold. Then I got my T value, intermediate threshold is 0.34. Okay, if some person don't want to this values, then that's okay. This formula, that's okay. You can derive your own value to calculate this T value. And here you need to apply some of the number theory of the mathematics. Okay. Then I need to use this I am binarized, because I told you the T always give you 0 and 1. So now I have given this converted image and this threshold. The converted image is what? The one I have already converted into IM to double this image, and I will pass my threshold. Which threshold I have calculated? 0.34. Now based on this value, it will convert my value 1 and 0. Okay, which one greater than that, make it 1, greater than 0.34, which is less than that, make it is 0. If we'll see 453 row and 443 columns is 1. 1 means definitely its pixel value greater than 0.34. Here you can see, yes, it's 0.399. So that's why it is converted into 1. So in this way, we have converted into 1 and 0. Now here you can see, this is my original image and this is my converted image. Actually, this part is the stroke part. But here one problem is there. Why we cannot give it as a solution, like a solution? Why is the limitation of the image processing methods? Why we need AI? Because when earlier people are using image processing method, it's quite good. Why we need AI? Because here we can see it is, we are just using a static threshold. You know, with the stroke region, we are also getting this region. Okay, like some other surrounding arteries. Okay, so it's some kind of a limitation. However, the plus point is, instead of giving the many like background noises, at least we are giving some of, we are reducing it, at least with our ROI, some of the defined part we are giving, because this region is already is like a defined, it should be there in our in the brain data. Okay, so the doctor can easily say, oh, this one is the common one, so maybe, oh, this one is uncommon one, oh, that one is, it might be the ROI, the machine can know this part. Okay, so this is the using of global thresholding. Global thresholding means you need to find a threshold T and you should compare it with the entire pixel of the image. And there is some example like the one I have said to you, like the hemorrhagic stroke patient data. Here, like how much adjustment threshold. Here you can see with a different adjustment threshold value, we are getting different output. The best threshold is like 0.6. We can get the approximately the region of the ROI. But if with other one, the ROI also affected. Okay, so you need to find that adjustment threshold. And this is also like one like image. Then here you can see with different one adjustment threshold we are getting. So in this image, actually the global thresholding is not really very good. Okay. Then what is the limitation of global thresholding? Why? Because global thresholding and also binarization is very good. Then why there is a concept of local thresholding is coming? The first thing is different intensity. Actually, this is one a brain tumor patient. Here we can see this one is like the tumor is already there and this is expanding. Okay, it's the MRI image. So here you can see the old part and the new part and also the brain tissue part is already, you know, like different intensity. So we cannot apply a particular threshold T to all those pixels. Then we cannot get the better ROI. For example, here also the stroke patient, here it is having an old stroke as well as a new stroke. Okay. So in that case, or maybe for example, like the part I have discussed about the people are restoring the books, the ancient books. Here you can see some part like this part and this part is completely new. Or if some kind of real life, we can to know the object detection, for example, roadside the car and everything we want to detect, then the intensity is very different. So in that case, why not we go for a local thresholding methods? So there are many local thresholding based methods I have already shown in a table, but the one like the adaptive, intensity, multi-level, region based and pixel based, this 5 was very much popular, but we are going to discuss about adaptive and intensity based, these three maybe some other time we will discuss. So what is this adaptive thresholding? This adaptive thresholding actually separate desirable foreground image object from the background when the difference in pixel intensity, just we say here we can get many intensities. This part is more lighter. Maybe lighter means here the pixel value is towards 230, 240 because the pixel range from 0 to 255. 0 means completely dark, 255 means completely white. So the value is around 220 after. Here the value may be 10, 11 or 12 because it's like darker. So different intensity values. So in this case, we will apply the local intensities. So similarly, we'll read the image, we'll show the image and convert it into RGB to gray. We have already. Then what is the function for adaptive threshold? The function is adapt threshold will pass our original image and some sensitivity value. It is kind of like it is also a threshold value that we need to adjust. Then the neighborhood size. Neighborhood size means on your entire image there will be like, I'll see if I can get pointer. I need the pen. Okay. For example, if this is your image and these are your pixel value like this, then if your neighborhood size 21 means there is a window will there, it will cover at a time 21 and it will check this pixel value, it will check with this sensitivity value. Then it will move to another one. Then after one turn, then it next go for another 21 pixel. It is the theory. Okay. Then it will move to another 21. So like this, it will cover. Okay. Then we'll go for the foreground and background polarity. Like what you need your foreground is like a darker or a brighter. If we need a darker, then we make it as a dark. If we need brighter, we need a bright. And considering this, then we have converted into IM binaries. Then here we can see this part is, if we'll see, at least now we can read the sentence what it is written. So this is the beauty of the adaptive thresholding. If you'll see with different sensitivity and neighborhood size, here we can see we can get the output. So that value, what should be your sensitivity value, what should be your neighborhood size value, with some kind of hit and trial, you can know better, because that value for image to image, it differs. Here also you can see from this image, we can get with different sensitivity and neighborhood size value. So this is about the adaptive thresholding. Then we will move for the intensity based thresholding. What is the intensity level thresholding? We some person also said it is like intensity level slicing. Here, like it will, this thresholding is highlights a specific range of intensities. Just a minute, I need to drink a little water. Okay. This one actually one person's lungs image during the COVID diagnosis. If you want to know like whether there is some kind of there is some already infected or not, the researchers only they are focused on the lungs. This like the surrounding part is not really much focused towards it. So our region of interest always takes a value. We find like when there is a constant threshold, okay, when we are applying the intensity, you know, the intensity of this organ will never change. Whatever the images you will take, the CT image or everything, the lungs intensity is always within 80 to 100 or 80 to 200, when the intensity will not change, okay, because every organ has some kind of intensity, okay. So the bone will always looks white, okay. Similarly, if you know there should be a static threshold between the static intensity between, we know the intensity of this organ should be 80 to 120 or 200 to 250 something. When we are sure about that one, then we can apply the intensity level slicing. So based upon their intensity, we will like segmented it, okay. So for this image, I am considering like why I am considering only the brain image, so that you can compare how the output looks like. But I have also in the example, I have already shown you the other images. Here for this one, I have considered because I know my threshold is in between 30 and 90. But it's the user defined based on your application and your image type and what kind of your ROI. You can define that R min and R max value. Then then I need to find out the size of my image, like what is the column and the row of this image. It's like 827 to 893. Then here I have like in the code, I have generally we like declare a array, like an empty array to store the pixels, the extracted pixels. I declare just an empty image array. Then here is the formula. So any this is my converted image. So if any pixel, if any r mean value, if it is less than that, then make it is 0. And if it the pixel, like the image pixel value should be in between r min and in between r max value. If in between 80 and 120, here should be 80 and 120, then any pixel in between this, make it is 0. Otherwise rest one keep as it is, okay. So when I use this, for example, here we can see this pixel values have some changes because that value is affected within the 80 and 120. What is the Armina Armax value I've given? 30 and 90. So it will impact only those part of the ROI whose pixel value is within to 30 to 90. Other the rest part is as usual. There is no change. The same thing when I applied it the MRI image of the ischemic stroke patient. Here we can see some of her the stroke, like it is growing, the stroke region, some of the old and some of the new. Actually here the what doctors requirement, doctors wants us to know, is there any new progression of there. Then we have applying actually different like the r min and r max value, the threshold value, to show okay actually there is a real progression or not. Here you can see this part, more darker part, we can get to know. This one is just like our ultimate aim, we train the AI machine to find out real progression or not. But instead of giving this image, if we will give this image, or then it can better know okay whether there is a real progression or not. This is kind of like a tumor patient. Here we can see up to this part. If we want to know the ROI, we can extract the ROI with different R min and R max value. That some for some images, when you get that value, then I think rest of the images is same. Suppose someone wants to work on the MRI image of the ischemic stroke patient, then it can know for some images it can get need to try for some hit and trial method for some to get that R min and R max. Once for the 10 or 20 images you find out okay it's not changing, then we can keep it as for all of our images. Then this one is like we have completed actually the thresholding based method. Now we go for the next part is the clustering based ROI extraction. Okay, so what is the clustering? Clustering means similar pixels, make it one cluster. Okay, For example, like in this original image, here I didn't put any medical image because to make you understand what exactly the clustering. I think you people have already read in some of your image processing because K-means clustering and all those things, FCM clustering are very popular. So I think you might already know the maths behind that. So here you like based on this different because this pixel value is one value, so one cluster. This part is another cluster, like so. This sky is one color, so another cluster. So based on your pixels, it will make you a cluster. We generally call it as an unsupervised method. Before that, we are giving some threshold value. It's a kind of like supervised method. We tell the machine, okay, this is my threshold. You need to change best, you need to modify the pixel value based on this threshold. Here, we are not going to give any kind of threshold value. We are going to like tell the machine, you please read the pixels, you please understand the pattern and make the cluster according to that. So there are many clustering methods. Mostly K-means and fuzzy C-means FCM clustering is used. In my work, I was used actually FCM clustering, but FCM clustering is a very lengthy method and many mathematics behind that. But I'm going to discuss about K-means clustering, and it's easy to implement also. Actually, the K-means clustering is an algorithm. Uh, in our mathematics also we generally use this part. So here if you want to calculate the distance or anything in between them, generally we'll start from to find out the number of clusters. This one actually user defined one, like up to how many clusters you want to define your like divide your images. Then you find the centroid, then to calculate the distance between centroid, then grouping them based on the minimum distance. Like in a class, suppose I want to group the students. How can I group them? Let's say I will say maybe the GPA maybe 8. Okay, so here 8 is the, I want to make cluster maybe in 4 groups, 3 groups, maybe high, low and medium. So maybe 9 I take the cluster. Okay, the cluster head. So now make the cluster head 9. So which is near to the 9, now I make to the one cluster. Then the cluster head will change because every time the cluster head will update until we are not getting 3 clusters. Now the cluster head will move to another one, maybe towards 75. Then all those will make another cluster. Now the cluster head will move. So until we get an optimum 3 cluster values, that value will be updated. So this is the math behind that. The similar one we have used and read the image. Here I have put k is equal to 3. I want the number of clusters equal to 3. And these are some of the parameters we need to find because we don't know which is going to be our centroid. So from our total number of cluster, I got a random value. Then the cluster center I store in an array. Then the maximum range and minimum range. This one is for the for loop, up to how much you need to go. We cannot run the for loop like for infinity. This is actually the code. Here we can see from minimum range to maximum range. Then we will find out, we'll update the cluster and then find out update the cluster centroid and find the maximum absolute difference between the current and previous iteration of the cluster. These are like the mathematics behind this, how the clusters are updating. And then if I want to put them in different color of the cluster, then the function is SCV. Then if we'll see the find out, I put 3 clusters. Here we can see one is just like the blue color part. This part it gives 1 cluster. Here you can see the little darker part it gives is also a blue color, and the surrounding brain tissue part it is giving is as the red color part. But you know in between some are the green color, little different intensity because this part is little bit lighter. Okay, so here we can see we got little bit green color. So this is some kind of image clustering we are using K-means clustering. Here for this MRI image when we have taken, if I put k is equal to 2, here it can give me the background as well as this part but with one color. If I put k is equal to 3, here I got this color 1, this color 2 and my ROI in a very good color, green color. But if I further divided the ROI, k is equal to 8, then here you can see this ROI gives me green color. Little changes gives me like orange color, and this one like the newer the progression one it give me in the cyan color. So that one also differ how many clusters you are going to take. So this one is like the brain tumor with a different cluster. How can we see the output? So this one is like the clustering one. The next one we will go for the contouring one. the contouring based ROI extraction. So what is the contouring will do? The contouring can be explained simply as a curve joining all the content, like it will operate on the boundary, or you can say clustering will focus on the pixels values, contouring will focus on the shape. It will like segregate the ROI, or it will segment the ROI based on where is the shape changes. Based on the shape changes, if it will find a similar shape, then it will make them 1 1 1 1. If there is, when there is a different shape, it will make them in another group. So here you can see this part, it find this shape is like a continuous one. Okay, in the contouring, the plossing part is you will find it will check the continuity of that shape. It will find this one is a continuous. Here we can see it is one color. This part it will find a continuous one and it will get another color. The surrounding part, here you can, the large atterage and the small atterage, it will find another color. It will make it as a blue color. And in between there is also this part, it will find the central groove part. Here you can find it can give you to another color. So this one is like we generally apply the contouring one in this part. When we want to go for the segment the image, or go for the ROI extraction shape wise, if we want to do. There are many actually. The famous one is watershed method, but currently earlier some publication was on watershed, but people have many varieties that one. But now the most popular one is the superpixel method actually. What is the superpixel method? The superpixel method, somehow it will like using the image segmentation, semantic labeling and object detection, and it is grouping the pixels here on common characteristics like pixel intensity. Okay, so if you will see this image, and this one is the ROI, here we can find there is a continuity. It will divide the pixels, and based on that it will segment it. Okay, these are some theory, it's not important. So here we are going to read some images. Then here is the function. Here we can see, we find out we read the image. Okay, then we compute the superpixels. Okay, for example, previously, how many clusters we want, we have divided into number of clusters. K is equal to 3. Here, how many superpixels you want means how many, we can say small cluster. Actually, here cluster is a wrong word. How many group you want? Okay, the superpixel group we generally said we can give it. So here is the function superpixel. It's a very good algorithm actually in between how the superpixel is calculated. Maybe we'll discuss some other time. Okay, so this is the original image. Then first one, you will go for the compactness. Compactness is because the structure of the image or the shape. For example, if you go to any artery or we go to central groove or any fissure, you will go. Then here you can find the shape, like the pixels you want very close or little delay. Means what exactly you want to focus on, particularly the exact shape, or little bit like even a little bit like little bit difference is also fine. That compactness also you need to find. Like if the shape is little bit changes, oh, also okay, we can consider them in one group. Or no, we need to follow the strict one. For example, if I say 80 should be from 80 to 90 should be one in one group. So 80.5 if one student is taking, so that 80.5 should be go on 80 group, or should we go on like the 70 to 80 group? That need to be decided. We are going to take the floor or we are going to take the ceiling. So that's the thing, like how compactively you want to show your result. And the method is the SLIC method. Here actually one paper is published in IEEE transaction and image processing. Actually this SLIC method is published. Now many methods have already been developed considering this one. But this one is like the SLIC method is used for superpixel calculation. This one is the method. And this one is the number of superpixel, like how many group you want. And this is the function to compute the superpixel. If you see the output, you will store L and N. So N is to store the number of superpixels. So from this image, when I give this image as input, this MRI image, this is the DWI sequence we generally call diffusion vector imaging in MRI. This is one of the sequence of the for use for the brain stroke data analysis. So this is the DWI image. So here you can see, although we are giving 20, but in our image, the model already know, no, 20 groups cannot be formed. 17 groups is the maximum one you can form with your image. So, and this is a numeric array. So this is this L value. So it contains the positive integer where 1 indicates the first region, 2 indicates the second dense region, and likewise 17, because we have 17 region. So all the pixel values from 0 to 255, it is already divided into certain groups. Okay, like 1 to 17 groups. Now we need to find the boundary because we don't know which pixel forms to which group. So we need to make a boundary. For example, one group we make a red color, another group make a blue color, another group make a maroon color. So like this. Based on this L value, L is contains all the values like the pixel value, all the grouping values. So based on this array, this is the boundary mask is the function. We gave the boundary. And then if we want to give any color to that boundary, okay, here I have given the cyan color. It's like I am overlay function. If you want to give some like a coloring value, here if like some transparency, I have give some transparent color for each group. We can go like here, definitely I got 17 groups. If you will calculate each color, definitely 17 colors are there. Okay, so this is like my kind of ROI. Of course, in this color, one person can ask me, because when this output I shown to the doctor, I had shown to the doctor. Doctor asked me, okay, there are different color. How can you know this one is my ROI? This can be my ROI. Okay, that's a very valid question. So although we used for the because at that time we are using for experimental purpose for superpixel method, but for this application it's not appropriate. Okay. Then what parameter you need to be tuned? You need to tune the number of superpixel and the connectivity. For example, here we can see for if this ischemic stroke region I have considered with different colors, like number of superpixel 20, connectivity is 15, and here you can see the connectivity is 15. Here connectivity is 5. Here you can see a more stricter boundary in comparison to this, and this is like some different values. So this is like my age-based ROI, this is my like contouring-based ROI extraction, which is the superpixel methods. Then we go for the age-based ROI extraction. This is a very good method actually. What is the age-based? It will focus on age of the ROI. Clustering focus on the pixel of the ROI. Contouring focus on the shape of the ROI. Age-based will focus on the age of the ROI. So what it will find, it works on detecting the discontinuities in brightness, because it will check where is the, because some pixel has some value, where is there is a discontinuity. What superpixel will check? Wherever there is a continuity. Age-based will check there is a discontinuity. Okay. If any person will ask you what is the difference between contouring and this is like age-based segmentation, you can say contouring will mostly focus on like the superpixel method. It's like where is a continuous. Here it will focus on where is a discontinuous. Okay. That's why if you see the output, always you get a continuous one. Nowhere it is broken. But here you can see we based on the intensity, we can get a discontinuous. There might be some breaking point in between. So here, what are the age-based methods? There are Canny, Robert, Sobel, Chris, Robinson, log age detection. There are many actually, but these four are mostly popular. Like Canny, Robert, Sobel, and Prewitt. Mostly these four are popular. We'll discuss. Let's go for the Canny age detection. This is a tumor. Okay, this one the brain tumor patients, and here we can see why the age-based is very much appropriate here. Here you can see this tumor is also spreading inside the skull. Here you can see it, not inside the skull actually. Sorry for my like the wrong word. It's just like it's spreading actually towards the brain tissue. Okay. So we'll read this tumor image, then we convert it into RGB to gray. Then for the Canny age is the function. We are giving the original image and the function name Canny. It is some kind of threshold because we need to find out like up to what, because it will see like the discontinuity based on the brightness. This brightness is nothing but the pixel thresholding value. And this is some kind of sigma parameter because this is a mathematical, like inside it will calculate. So we'll give this value. Then we can see this is my original image, and after Canny age we are giving, you see, we can get the tumor part. And if you'll see here, we can see this part, it is already started spreading. You see, there is a, this is the original tumor, but this part is already little bit start spreading. And this one, if you go for the robot test, similarly, the function, the image, and the function name is Roberts, and also the 0.13, nothing. Nothing means you need a thinning line or a thickening line. If you need a thinning ROI, you just give it a nothing. No thinning. If you need a thinning, then you need to give like no need to mention anything. If no thinning, then you need to give like a no thinning. Okay, because the default is thinning. Then here you can see we can get like this. Okay. Now if we'll move to the next one for the Sobel edge, here also the Sobel function, then this is the threshold value, then you will get this type of output. If we'll go for the pre-weight, also we like mentioned the pre-weight, and this is the threshold value, then we'll calculate this value. Okay. Now if we'll compare, if we consider this tumor image, and then here we can see if applying Canny, this one is the output. If applying Robert, this one is the output. If applying Sobel, this one is the output. If this one is Prewitt, this one is the output. Most probably, always the Canny gives us the better result. We find in medical, although these are very popular, but Canny sometimes gives us the better result. Oh, this one is very important one. Actually, it's the cyst patient actually. Here you can see in the liver, here you can see there are the cyst patient. Here you see the doctor wants to know whether both the cysts touch each other or not. Because if touch is there, then there is a high chance of cyst bursting. Okay. So in that part, we need to find out the boundary. So we apply like different threshold methods to check out whether there is a real touching or not. Okay. Here you can see. So this is all about like how the edge-based method or how the methods we are used for the ROI extraction or image segmentations. Then the next part is the cropping one. I know you have several questions considering the segmentation method. Probably, please note down your question, and we'll finish the class maybe like the session maybe 10 minutes before. Then we go for the discussion. Okay. So the cropping. The cropping, you know, because I have already discussed some unnecessary part we need to remove. So first that cropping will like this part I have already discussed, like we need to crop to only get our ROI. So the cropping, there are many algorithms. I'm going to discuss like some of the algorithms, and some of the predefined MATLAB function. So the first one, the derived algorithm, what actually I personally used in my algorithm. This one actually I want to know crop. Here I find out the size of the image, like what is the row and column of the size. Then I find out the non-zero columns, because you see this black color means the pixel value is 0. I have already mentioned. So I need to find out how many non-zero columns and rows. Then I found the top row, minimum non-zeros, maximum non-zero rows, minimum non-zero columns, and maximum non-zero columns from this one. Then I found these are the pixel value. Then I crop the image, original image, top row to bottom row, left column to right column. Means I got from this value to this and from this to this. See, after getting this cropping from here, I got this one. Okay. So this is one of the derived algorithm I have used in my code, because this is the complete black background. Okay. But if it is like different other background, then yeah, also we need to see what we need to do, what could be the intensity and what should be the algorithm. For example, also you can give some kind of like a static value. For if I want to just for the cameraman is standing there, then I just like convert RGB to gray. This part you already know. Then the rows and columns I found, the image size is 206 plus 205. Then I found the top row, bottom row. Here I am giving some kind of like static value. Okay. Then user can modify those values. Then from this, from 20 to 30 and 160 to this part, we can crop this part. Okay. Because this is the formula from top row minus to bottom row, from left column to right column. Okay. Then I got this value like original image from 30 to 196, 20 to 160. We got, then you can see from this is the original image and this is my cropped image. This is also one way. And also in the MATLAB, they have also like a function called IMCrop. It's automatically there. You just need to put your mouse inside that and right click it. And you can just like immediately crop the image, and you can also crop the image. But that one is the code way, is very efficient. Like within second with one code, you can generate like more images, more cropping at a time. You need to do these things is like manually. So this is some functions related to cropping. Okay. So next we will move to image data preprocessing, considering the morphological operations. This one is little important. You please pay attention to that. What is the morphological operation? Actually, morphology is used to process based on the shape. Like it will operate on the morphology of the image. Morphology can be anything. Morphology can be texture. Morphology can be pixel values. Morphology can be size. Morphology can be intensity. Morphology can be, because if I say the morphology of an object, morphology can be anything. One person can say, oh, that object is shorter. Means shorter can be shorter, long, that little short and long, fat or thin, white or black, or maybe a little bit thinner or thick. So this is some kind of morphology. Who looks what? Okay. So that one is some kind of a morphology. So if we want to do operate some kind of morphological operations over the image, there are some function: erosion, dilation, opening, closing, top hat transformation, black hat transformation, morphological gradient, where we can apply what we will discuss. Okay. The first one is the erosion. Erosion means, because we already know in English, erosion means removes islands or small objects. Okay. So this is the form, like the, we generally write it like this. If there is an erosion operation, so it will remove the isolated noisy pixel. If any noisy pixel around your ROI, then it can remove those part, smoothness the object boundary, and remove the outlier of the object pixel. Object becomes slightly, if any, like if you want to remove any of the smaller objects, suppose you want to keep the bigger one, the bigger size of the object, and you want to remove the smaller one, then you can apply this one erosion and separate touching object also. Here here I have not taken any medical images. At the end, I will show you the why when we took on medical images and apply all those operations. But to understand you the functions of these morphological operations, here you can see here erosion. What it will do? It will keep the smaller objects. Okay, so it will keep the larger objects. It will, the noisy pixels or anyone which have the smaller size, it will just remove those part. So here I read the image. Then we need to function, we need to declare the structuring element. That one is very much important. What is the structuring element? The function is strel, whether it is a disk set. This one is the radius we generally give. But if it is a disk set, it will work on this pixel. Means if you start from here, and if this one is your radius, then it will up to this one, up to this diamond shape, which pixel are there, it will keep them, like include them in the analysis. Rest are just forget, like 0. We generally call this one is the true, this one is the false, or include or ignore. If it is like a radius, like you can see like this shape, then here I give radius is equal to 3, like a disk shape. Here it will consider, if this one is the origin, 1, 2, 3, it will just consider these images and ignore this one. Let's take one example. Okay. If this is my image, original image, and with this pixel values, and here is a disk shape, I have considered like radius is equal to 2. Here, this is my original image. This is 1, 2. These are my true pixels, which are going to include in the output. These are the false pixel. I'm just ignoring those. Then it will, the structuring element will move. First, it will include 122 and ignore 111. Then it will move here. Then it will like this. Like this, it will move and include 1, ignore 1. Okay. There are many actually. There are diagonal shape, octagon shape, rectangle shape, square, cube, cuboid. Many like in which shape will give the better one. You need to also do the experiment. So now I use the function I am error, original image, and my structuring element I have given. Here you can see this is my original image, and what we will see, the noisy pixels or any pixel which is less than that is already not there. But however, the impact one, if this is on your ROI is getting little smaller also. Okay, so that one, that structuring element, you need to also think how much you need to give. So this one for the erosion. What erosion will do? It will remove your noisy pixel and make it like your ROI also a little bit smaller if you want to make. Then the next one is, this is the erosion. Some example here I have given, like if this one is my image, and if let's say these are my ROI, so I have given the structuring element such a way that here we can see I've only get this one. If this is my input image, I want only the 1, 1, not the 0. Here we can see with the structuring element square with 2, here we can see all the zeros values are already gone. So this is kind of like an erosion. Then dilation. Dilation will work like opposite of the erosion. Erosion make it smaller, and dilation will make it like the size be like the bigger of that one. Your ROI is become like little more. So dilation expands the connected of the boundary, and also filling the holes and the gaps and smoothness the boundary. So similar way, I have considered this image, and I have used the structuring element disc shape with radius 10, and IM dilate function I have used, and here see it's bigger. Earlier one you can see it's already gone, smaller one, here it is getting bigger. So this one is the IM dilate function. For example, if this one is the narrow one, we want to fuse this one, in between this one, we can use the IM dilation. So suppose if there is any holes in the picture, if we want to cover it, then we can use the IM dilation. Then go for the opening. Opening is erosion followed by the dilation. Okay, so it is used, eliminates the protrusions if there is anything, breaks the neck, smoothness the contour, and close small foreground from the boundary. So this is fast erosion followed by dilation. So first it will erode. For example, this is the image. I am using IM open function, original image, and this structuring element. Here we will see this kind of out. So fast erosion. Erosion means this part already moved. Dilation, the part with erosion, this part already reduced. Now with the dilation, it is all again restored. So this is the opening, erosion followed by the dilation. Then this one, like for example, these are some outputs. Then the next one is the closing. Closing is dilation followed by the erosion. It is also fuse narrow breaks, eliminate small holes, fill gaps, and helpful in closing small holes. So here, for example, I want to close these small holes in between. For example, I'm using IM close. To realize this, I have just changed the image. Now I have using this image. So IM close, I have using the original image and the structuring element. Here you can see this part is already closed. Okay. So this one we are using IM closing. Now, for example, there is a narrow breaks. You see in this image, there are some narrow breaks. Through this closing, we can already close this part. For here, this one, like if this small part we want to just remove, we are also applying some of the closing part. Here also, like dilation followed by the erosion. Okay, this one is the closing one. The next one is the top hat transformation. Top hat transformation, the input image minus opening image. So the white top hat transmission part, it will return an image containing those objects or elements in the, you will get that ROI which is the smaller than the structuring element and brighter than the surrounding. Keep this in mind. Less than the smaller than the structuring element you are giving and brighter than the surrounding. So when I give this image, I got a structuring element of this is shape of 8 and I am using IM top hat function. I get this output. Here we can see it will give those images which is smaller than the structuring element. So if these small stars are the less than the smaller than the structuring element, so I got those values and also brighter than the surrounding. The small stars are black background, so it is brighter. So we only got this part. So this is the top hat transformation. These are like some example. Here we got, suppose in this part, we only need this 4 dots. Then we can use after the top hat transformation. Then you see we can only got this 4 part. Okay. So this one is the top hat transformation. If we go for the black hat transformation, it is closing image minus input image. It will also give you the smaller, like the ROI, which is smaller than the background of the structuring element and also darker than the surrounding. The top hat give you the brighter, but the black hat give you the darker one. So if I use this image, and I use the same disk set with 8 the radius, and I am both hat is the function. Here you can see it will give one which is the darker one, the surrounding, okay, and also the black hat image. So this one is like the black hat transformation. Then what we will go for the morphological gradient. What is the morphological gradient? The formula is dilation minus erosion. Okay. So for example, first it will dilate minus erosion. Actually, generally morphological gradient we need when we need the exact shape of that ROI. For example, I want to know the exact shape of the horse. So here you can say horse DPG. This is the original image. Then I apply the structural element square with 3. Then I apply IM dilate minus IM erosion. Here you can see we got the exact boundary of that one, the ROI. So this is like the morphological gradient. These are some functions. Okay. Now, where one real application, how we apply this kind of like this morphological application. Actually, we have not applied only the morphological operations. We applied in between. Like we need to find out this only the cyst part. We want to segment this ROI. So this is the liver cyst and converted into RGB to gray. Then, like for example, this is the non-contrast one. So I have using is the IM guided filter. Then I converted into IM double to make it enhancement. I use the guided filter, then change it to IM to W, then binarize I converted into. But I have not just used binarize, I have also used a threshold 0.4, like the global thresholding. Okay, the 0.41. Then I converted into the binary one. Here you can see now I got the cyst one. Then I have used the area open value, the open function, but with as it is a binary image, the value is BW area open. Then with the 800 is the value, like the threshold value. Then here I can got more like the smoothness in the image. Then we go for the closing operation. I am closed. I am this image, and with the neighborhood. Neighborhood is nothing but the structuring element, how much size I have needed. Here we can see I got the area open, sorry, area closed. Then I converted what is my original image and what is the img close function. Then I have just give me those image which is same from the original image, take those pixel which I got from the img close. So after this I just got this output. Okay, now instead of this whole image, now the doctor can only focus on, or our AI model can only focus on the cyst, just forget about the surrounding. Okay, because sometimes the intensity surrounding also for the AI model training, some kind of the also have impact. So that's why not just remove the surrounding? Okay, so just keep the ROI. So this is some kind of operations. So while this is all about today, actually, while we are I'm explaining, I think sometimes I'm a little bit fast because we need to finish all those parts. And I think you all have many doubts regarding the functions and all those functions. But one thing I can say, if any person has questions in their mind, which function needs to apply where, that we cannot say. Of course, we need to go from we need to go for some hit and trial method. Then we can find we can know which method is appropriate. And like for example, the SLIC method I have shown for the DWI image of the ischemic stroke patients. When doctor asked me, although you have segmented it, but which cluster I need to consider, that we have no answer. So like this, you need to think which method should be applied here, what could be the appropriate value, and all those things. For example, here I can use global thresholding. In this application, here I used area open, here I used area close. But that might not be appropriate in other images. So that also you need to think. Okay, any questions, please?
Ananya Chaudhary, you can ask the question.
Hello, ma'am.
Yeah.
Ma'am, in most of the medical images, the tissue intensity is often overlapping in cases. So,
Yeah.
in those cases, how do we decide that whether we should use the threshold-based segmentation or we should directly, go for AI-based segmentation methods?
Oh, yeah, you actually hit the nail. That's a very good question. That's where the image pre-processing method fails. Okay, that's why
Okay,
AI
ma'am.
comes to the picture.
Mm-hmm.
But you can use directly the AI image, the segmentation method. We can have label. Okay, this one is this part. This one is this part. This one is this part. Okay. But
Yes, ma'am.
sometimes, yeah, but what's this image segmentation method? That's why we are not going for its image segmentation method. I name it as the ROI extraction. Okay.
Mm-hmm.
Maybe your intensity is not like overlapping intensity. Maybe I'll give you some example. For example, it's not like everywhere we need to apply the thresholding. But let me go to that one, thresholding one.
Yes, ma'am.
Just a minute. I need to go that tumor image so that we can discuss more. Where I put that image. Okay. We just come here. Yeah. Here you see, this one is like a tumor patient. Okay.
Yes, ma'am.
Here the intensity is very overlapping.
Mm-hmm.
Okay, even if here AI fails, honestly, when I was working in that image, even if I train with a different color, I give it as a new, give it as a old to the machine will cannot also know because the intensity is very nearer. Okay,
Yes.
but in this case, why we apply ROI extraction? Forget, like you are going to give this one, like you are not going to segment that this part. Okay, you are going to extract only this part. Inside that, what we will think, how to train our ROI, which method AI we need to do, what enhancement we do our operation. But here this is our entire ROI, that's the tumor part. Here
Yes.
the main intention is through image processing, just discard the outer part. Okay, we just
Okay.
we just only focus on this ROI. This is our region of interest. Inside our region of interest, is there is a change in the intensity? Is there is a change in the value? Is there a change in the shape? That is another part. That one AI comes to the picture. Okay?
Okay.
But before that, we need the ROI extraction just to remove the unnecessary parts. Okay?
Yes.
Okay.
Okay, ma'am. Thank you.
Yeah.
Yes, Vivek.
Good
Vivek.
afternoon, ma'am.
Yeah.
Is there some diseases where the image or structure of the organs remains almost the same as healthy organ? And if yes, whether AI or doctor can detect those?
Like you say, if there is a healthy patient and it comes like a patient is not healthy, how to differentiate?
Yes, if the
Yeah.
organ structure is almost same, healthy
Yeah,
and the
means there is no difference yet. Oh, you got the best. Actually, my PhD past paper is related to that. When an ischemic stroke patient came, maybe tomorrow when I will teach you the CNN, I'll put that image. Actually, within 24 hours, the doctor cannot see anything when we got the non-contrast CT. If some doctors are there in this, I found in this seminar, in this workshop, they can also know. They can also tell, like within 24 hours, within 12 hours, when a patient comes to the emergency, when a patient came, doctor cannot know whether it is a normal patient or whether it is a stroke patient. Okay, so at that time it's very difficult to distinguish. So we trained our AI model. Actually, that part tomorrow I'm going to discuss how AI can help us to distinguish whether this is a normal patient or that is an ischemic process. Actually, in that paper I have only used only one pre-processing method. That one is the noise removal only, because I want to do some enhancement, because in that image, actually it is a non-contrast one, so we cannot know actually this one, like where this was. To make the enhancement of the picture, I only applied only one noise removal method. Rest part is taken care by the AI one. Maybe on the 28th of that one discussion, I will show you that paper, how we have distinguished this is a normal patient or this is an ischemic stroke patient.
Okay, ma'am. I have a following question.
Yeah, please.
But
First question clear?
Yes, ma'am, I got it.
Yeah.
So if AI can detect those, the question is, every human should have different patterns or unique structure like fingerprint. Everyone has unique fingerprints. So is it possible that we can detect the AI can detect the damage if they have not the previous data of the patients?
Oh, means if this is not a continuous study,
Yes, ma'am.
like at a particular time instance, it is, we generally call in clinical, it is a longitudinal study. If it is not a longitudinal study, then we'll focus on that time instance, what happened. We can only tell the severity at that time. Okay,
Okay,
but we cannot say this severity is because of some of the previous things or it's just now happened.
Oh.
For example, I don't know what's your question. What I got, for example, a patient, we got one stroke image of one patient. It suddenly is said, the doctor said it came to the emergency around 2:30 of the night, and at 4 o'clock there is a big stroke, like the hematoma is very high, very large, and doctor is also, like, how come within 4 hours the hematoma is that much large? oh, when we check because that doctor, when we go to the like back, at that time, we said, okay, yeah, it's a very risk patient, and they did something. Our AI model predict it's very risky, and all those things. But actually, that stroke is not because of the brain stroke. Actually, he has a big embolizing, like a intracranial stenosis. That stroke happened because it has a big blockage in the stenosis, like the our from our spinal cord, the one which connected to our brain. In that, they have a big occlusion in that. Doctor has no idea. Even if doctor gave too much treatment, but still that hematoma is still there. Means like the ischemic stroke region is still is there. That the region is, but they cannot know the ischemic stroke part, like why it's even if so much treatment, it is we are not getting any cure, or there is no, because that is not the problem. The problem is somewhere else. So sometimes also, the because of some previous things, the current things also happen. So nowadays, that's why we encourage patients to go for a longitudinal study. We now know more. Earlier, when we did the experiments, we always do at a particular time instance, but now we always go for a longitudinal study of the patient. And the other questions you have asked, like the fingerprints, the person's like the change, yeah. Actually, the fingerprints, the person organ not change. Wherever the liver it is, it should be the liver it is. Yeah, the appearance when I walked in a liver cancer patient, that one also varies. The SCC in some patients, the look how it looks is vary from the other patient, and also the intensity varies, and the shape size it also varies. So that one is also a tricky. So we need to train our AI machine in such a that. So when we for that work, when we did the experiment, we have categorized the patient. First, the patient is cirrhosis or not. First, then size wise, then age wise, then the gender wise, then what is their clinical value at that time, what is their AFP value, there are all those values. So there are many analysis actually we need can do. But yes, AI can do fast things. And second thing is, yeah, the longitudinal study is much more appropriate in comparison to a particular time instance. Am I clear to you? Or
Yes, man. The longitudinal study, that was I wanted to know.
yeah,
Yes,
yeah.
I got
Oh,
it.
Now actually we always encourage the clinicians or physicians to give us the longitudinal data to for better prediction.
Okay.
Okay.
So there are another two questions are there in chat box.
Yeah, please.
001. Okay.
Yeah.
Yes,
you
sir.
can
I
answer.
could not change my name, so I
Yeah.
apologize
Okay.
for
Yeah,
that.
you can ask me. Yeah.
Ma'am, as I have already written in the chat box, the question is like there are instances when images of a particular organ have similar I mean, like when symptoms are similar, usually the diagnosis, when we diagnose, the it also shows similarities. There are certain instances, so which can be indicator of, which might be an indicator of two different diseases,
Oh
and
yeah.
the difference can be caught only by the clinical eye of the doctor. In
Yes.
this case, how can we enhance image processing, or how can we train AI models?
Oh, okay. The question you have asked actually is a very important question. It's a very important question. Uh, Honestly, the image processing methods we have used today is just for the initial part. When we got the raw image, got from the doctor, we just cannot take it for the AI analysis. We need to do some pre-processing, just like maybe noise removal or enhancement increasing or some kind of ROI extraction, or like small things. We cannot go for directly to the conclusion, directly to the outcome. It is some kind of like pre-processing. When we want to make the chicken curry, we need to do some pre-processing. We just cannot take the
Yes,
chicken
ma'am.
from the market and just we cannot just make it cook. Okay, we need some pre-processing. We generally do some kind of like garnishing and all those things. That's the thing. The second question, when you asked about when there is a similar things, actually these things happened when especially the ischemic stroke is always happened, like the one I explained to the previous student, like it's very difficult within 12 hours to know. In
Yeah.
the liver cancer patient, what it is happened, if the patient is having one cancer SCC, another one is cholangiocarcinoma, sometimes it's overlap actually. But that two type of cancer has two different type of medicines and treatment procedure. So sometimes the AI model we have developed, it is say SCC to cholangiocarcinoma, or two having SCC or two having cholangiocarcinoma. Okay. So at that time, what we did, generally the doctors actually, what that time we are taking the clinical also the report of that, because some of the report of SCC is different from the cholangiocarcinoma. Like there is some avapiloprotein, there is some other variables are there which are only dedicated to the AFP or sorry for the SCC, and some are related to the cholangiocarcinoma. So honestly saying, only from the image we cannot get a conclusion if the diseases are very overlapping.
Okay.
At that time we are taking another model. Okay, that one is the clinical data. That's why currently, actually, I found Dr. Pushpanjali Gupta. I think on the first day, she's going to give a very good talk related to multimodal data analysis, different case study.
Okay.
So here you can see, because today we are only discussing about image. It's the single model. She's going to discuss about multimodal, I think, because how not only image gives us a conclusion, we need also clinical data, we need also we generally call their demographics data, their gender, their age, and all those things, their living history, whether the person is smoking or not, taking alcohol or not, whether there is hypertension or not. So all these things together can give us a better model. Through single modality, now honestly cannot gives us 70 like 100% accuracy, maybe 60 to 70. Doctor needs still their intervention, we need their experience, but multimodal is very good.
Okay.
I think another question is there, Sulagna, here.
Yeah, please.
Arnis,
Yeah.
from your experience, how do clinician and AI teams handle situation where the same anatomical region appears disease images?
I think the same question asked the previous
Okay,
student.
fine. So answered.
Yeah.
Any other questions, or we should stop here so that at 3 o'clock we can start another session? Yes, Arnis, if you want, you can.
Yes, actually, where do experts see the highest risk of introducing misleading information, and how is the risk is controlled?
Anis, can you be a little bit louder? you are like asking a very good question, but little more louder.
As I written in chat, like, how do the doctors and AI teams handle the situation where the same regions appears diseased in images from one machine but appears normal in another image? So where in the full medical image processing pipeline, where the uh, highest risks are there in misleading information, and how the risk is controlled?
Means you want to say like if one machine say machine means you are saying the scanner machine or the AI model?
Scanner, yes, ma'am.
Scanner machine, like okay, you say like if I'll go to the one scanning machine, if it is not there taking a good vendor, then it will giving no disease, but another good vendor, it will say like there is some disease.
Yes.
Oh, okay, that one also, like we generally call it is a multi-institutional study. Okay, now
Okay.
if you are studying like many AI papers, in the limitations, all the authors always said in our future one, the current study is a single institutional study. In future we would like to go for multi-institutional study, because if we go for the multi-institutions one, because if we focus on one machine, one hospital, then maybe we got a data bias error. Okay, our model can only know what that machine will say. Okay, it has no idea what other machine has say. If this machine say there is no disease, then our AI model can only know, okay, there is no disease. Okay, but if there is a disease, but the same patient will say there is an ROI or there is some abnormality, maybe some other hospitals, that the first person go to the hospital A, and our machine is trained with only the data of A, and in that patient, let's say XYZ at hospital A, so no disease. If our model is trained with that and it is already biased, then but in hospital B, the machine is very high performance, and it will say actually no, this patient is having the abnormality, then our model at that time cannot predict. That is a big limitation. That's why now many AI paper rejected because of that. Because if you will go for the single institutional study, even one of my paper is rejected, honestly saying, because of that only. because we have done a very good work on that, but we have just only focused on one hospital. We have not focusing on the other hospitals. Then that person asks if this person is go for the other hospitals, and if there is a study of that one, you have not included in your study. So that also we need to think. We need to go for the collaboration with multiple hospitals, so that the model can know the machine parameter, because the image parameter from different hospitals to get the better outcome. Okay, because I found the Philips machine, the MRI machine, if I comparison with Siemens machine, the Siemens machine has better clarity in comparison to Philips machine. Honestly, it's my personal differentiation, I can say. So that's why we always encourage now the physicians to go for a multi-institutional study, no for the single institutional study. Okay,
Okay, ma'am.
am I clear,
Thank you.
or you have still a doubt?
No, ma'am. Thank you. I got it.
Okay, please don't keep any doubt with yourself. If you want to continue future in the AI, just ask us question. It's not like everything we know. We can only tell you from our experience, because AI is very vast now. Okay.
Yes, Abhishek, quickly ask the question, Abhishek. Yeah, Abhishek.
Ma'am, if we train a AI model in India from Indian people, will it work in some other climatic country like Greenland for this?
Oh, that one just I have answered. Sometimes the model is biased with the from that hospital. It's like
local,
India means,
yeah.
if you have considered India multi-institutional, then I think it might work, because the city, let's say the non-contra city, even if I found the hospital I worked, like I have collaboration on that, they have a very good private hospital actually in Taiwan. So their machines are very good. But when I got the images from the local hospitals, like the public hospitals, it's not very good. And their images are not at all very good. Even if I can't see the brain tissue, forget about the stroke region. Okay. So generally, when we are going to develop a model, we always we want to go for whether we go for a already developed countries or the developing countries. Okay, we need to also see. So I don't know, when you are saying like we are to apply the, if we have go for an India and you have developed one model, how much it will work on outside. If we go for a clinical model, for example, the blood test report, we generally call the categorical data or the textual data or the numerical data, it might work, because the blood test report might not vary. Okay, because if someone's like the BP, all those values, or go for the hemoglobin and those values all over the world, it is like a similar things. But if you go for the image wise, it also vary. It's based on the, actually it's based on the scanner, I can say. So that we cannot sure, that we need to go for the experiments.
Thank you.
Okay.
I think last question you can take, then we'll stop.
Ma'am, my question is that the all image processings and all that methods that we have shown, so it's mostly based on colors and the shape of the object. So is there any other features also that we are supposed to look into the image, specifically biomedical images?
If we go for the image pre-processing, we generally go for the texture, color, shape, pixel intensities for the medical images. These 4 things we generally go. Generally, because but there are morphology considering all those. These 4 and 5 things we always consider. Mostly we go for the pixel values. Mostly. The shape and all those things come to the latter, but if any kind of pre-processing we want to do, the first focus always should be on pixels. Okay?
Okay, ma'am. Thank you.
I think no questions are there.
Okay. If no question, Professor, I would just like to say tomorrow we will start the convolutional neural network, actually the AI analysis part. So that one also, like hands-on, I'm going to discuss about some coding part and how the data you are going to build and all those things. So tomorrow we are going for the analysis part. So if anything related to the analysis, tomorrow we can discuss related to that.
Ma'am, I have one more question.
Yeah.
Ma'am, this AI/ML analysis and that in biomedical, so if we see that it involves like mathematics, because without mathematics, AI/ML is like almost nothing. So mathematics is there, then AI/ML, we have several amount of modules and programming languages to learn. And then comes the biomedical where you need to learn basic biological understanding to. So my question is that how are you able to handle all this all together? Because
Oh,
mostly people.
oh, your question, took me to my student when I was a student. Okay, my background actually computer science. Okay, I started AI at the year 2018. We got my professor, actually my advisor, got one project related to ischemic stroke data analysis. At that time, I only know, okay, there is stroke happened. I have no idea on what's going on and all those things. But one thing I'm very lucky, and like the doctors we collaborate, they are very friendly and they are very good to give us the knowledge. We don't know much knowledge. What's exactly that things? We only know to know some, we only get to know some minimum things what we need, like a first thing, what happened, so that they call it is a stroke patient. Okay, what happened if they call it is like, what is the difference between the stroke and non-stroke patient, then what parameters they have considered, like just like we want to think like a doctor. Of course we cannot be a doctor, but we can think like a doctor. So for this, for if you like to go for some kind of a biomedical things, then honestly you need to spend some hours to gain some like the basic knowledge related to this. And of course we need the huge collaboration from the clinicians to get to know this knowledge. And this is about the clinician part. We need doctor's help actually to get to understand what are those things. And if we come for the coding part, for the AI part, there are many models, there are many things how to go for that one. Actually tomorrow we are going to discuss this part, but the three things is, enter anything in this world, that always go for, either you will go for a classification, you want to go for yes or no, disease or non-disease, or you go for a detection one. If disease, where is the disease? Or you go for a segmentation one. You want to know the severity. I am talking about the image one. Okay, we are not discussing about the clinical data and all. I'm going to about discuss all over the image, these three things. Either we go for a classification, either we go for a detection, or we go for a segmentation. So based on that, first you need to find out what's your motive, what you want to do. Then we go for, if we'll go for no, we need to go for a detection one. Then there are detection many methods, one stage detector, two stage detector. Then what we need to decide, we'll go for like actually there are many things we need to go step by step. Okay, uh, but the one thing is we need to spend time, we need to gather much knowledge to go for it. That's the bottom line.
Thank you, ma'am. You means that grabbing the knowledge according to the need. I mean, in
Yeah,
case of
actually that's the thing. Now what the students are doing, they are just reading from the chat GPT or Gemini, and they are saying, ma'am, we learn these things, those things. Yeah, these are a very good platform to study, but I always think that first decide what to study, not just write okay in the chat GPT, and it will give you. Now the chat GPT 5.1, I think already there, it gives us like a 5.2 already gives you like 2 pages of like output. That we not need it. Ask the chat GPT the right questions if you want to study from the chat GPT. Just the right question and the appropriate one. Okay, now the persons who are working on the LLM, now many people are developing the AI model like the chatbot. They are, they are not getting the accuracy because of, why, because they are training the machine with some garbage kind of prompts which are not really necessary. You should train the machine what exactly should be the prompt, like a doctor. So that's the thing. First you need to decide what to study, understand your problem statement properly. That's why
and
doctor needs it. Not doctor needs us. Doctor knows the problem. Okay, doctor can tell us, I want to detect what is the tumor. So that's the word actually. I want to detect the tumor. Okay, then the problem statement is that for the detection, then we come. What type of detection method we will use? And there we need to explore. We need to actually study many literatures, many papers. Don't rely on more on the chat GPT or the other open sources. Please read the manuscripts. People have already, publish the papers because the papers are from their experience. Read those.
Ma'am,
Yeah,
I'm sorry to interrupt.
yeah.
What I wanted to know is, I mean, like, since you have explained whatever you explained today on image preprocessing,
Mhm.
in short, I mean, I want to read into the details to understand it better. Could you please suggest me any resource?
Oh yeah, sure. Maybe I will send Professor Das some of the books and some of the links from where you can get. to know these things.
Yes,
Is that
yes.
okay? Maybe
Yes.
later Professor Das will share this.
And the video of this session will be uploaded today only.
Yeah, those things, and from where you will get to
And
know.
send the resources. I will send to the.
Yeah,
Okay,
and
ma'am. Thank
for
you.
the future one also, and also like I have also put some link also here.
Actually, in the introduction only, introductory session only, in our session, it is very clear. We are not here. The objective is something different.
Yeah.
The students, those who are very good, okay, can attach with us, okay, do the research or any type of, not only publish the paper, that is the secondary things. Okay, so if you want to collaborate with us, do some work, then in the long term also, ma'am is there and other resource persons are there to help you. Okay, so any
Okay, sir.
research you want,
Actually, we are there to help you, what Dr. Das said, because when we started AI, everybody is new. At that time, only AlexNet is only one model is there, But now it is very vast, and we can also guide you. It's not like we'll teach you. We can guide you, like in which way.
last year also I have conducted this type of workshop. Around 600 plus participant was there. But whenever we go to the next step, we have conducted various sessions. Okay, to whenever we are going to assign the work to them, then 600 come down to 60. Then after whenever we get the second assignment, it come down to 6. Then vanish. Got to our point. So here, not like that. So that's why I've
Okay, sir.
taken only 80 to 90 students, and out of that one, we'll give the assignment. From 80 to 90 students, we'll select only 10 to 12. Those are very good after 1 month. Only because we are going to give our resources. Time is our resource. We are
Yes.
put time, so getting on that. So if you are really serious, then definitely we'll think for that one after the.
Sure, sir.
Okay. Thank you very much.
Any prerequisite for tomorrow's class, sir?
For tomorrow, about my part, my session part, I think no need.
Okay.
Because it's like from the beginning, just like we started from the image pre-processing from the beginning.
Alright.
But if you will get to read some about the convolutional neural network concept, please read it. So that when I will explain it, then you will get to know, oh, yeah, that part I have already read it. So that you
Okay.
can connect. Please have a read on the convolutional neural network. Then it will get more easy.
Okay, then I think we'll stop here.
Thank you very much. The section is very interacting, and hopefully it will continue further.
Yes. Thank you, Sulagna ma'am. So
Thank you,
I
sir.
see tomorrow. So another session is there at 3 o'clock. Okay, all of you just join. Thank you
Okay.
very much. It's from
Thank you.
Vietnam.